Hello, and welcome back to another episode of Mr. Walker's Apes. Continuing along with Chapter 14, we're going to talk about more about the environmental problems. So a little bit of social problem last time, now the environmental problems with food production. So this is sections 3, 7, and 8 of your chapter. Okay. So first, just kind of a general overview here. These are all problems that we are facing right now with food production. Land degradation. Land degradation is the natural or human-induced process or processes that decrease the future ability of land to support crops, livestock, or wild species. In other words, it's land that we can't use to farm and make food on anymore. All right? And that's a really big problem, especially if you have soil erosion, like in this picture. If your land is just washing away from you, it cannot be used. All right. Pollution from fertilizers, pesticides, big problem. Irrigation. All right, this might be a new word for many of you. Irrigation is the process by which you water crops. Okay. So if you don't have water for watering crops or for irrigation, that's going to be a problem. We're going to talk about overgrazing and desertification. How do you take a semi-arid area where it might take a year for grass to grow, then you come along with cows and they eat all of it in a day? Well, over time, the grass is going to stop growing there, and that allows for the expansion of deserts. So it becomes desert-like, so desertification. We're definitely over-harvesting fish. Oh my gosh. We're going to talk about something called the tragedy of the commons in class. And this is basically if you leave everything as a common good, then eventually humans are so greedy we just use all of it. And we don't even realize it until it's gone. The removal of net primary productivity and other ecological services. What happens when we overfarm something and now nothing grows there? Okay. Why are not monocultures less productive than polycultures? That sort of thing. We already talked a little bit about distribution. Okay. Right now, places that can afford to distribute food are very well off. Places that can't, not so much. How much energy do we use to farm, and where does that energy come from? And what does it mean for succession? If crops are early successional species, will we ever reach a climax community? And does a climax community have higher net productivity and biodiversity than another one? So you've got all sorts of problems. Oops, I apologize for this. Okay, so moving along then. The first set of problems. We're going to have a biodiversity loss. All right. There's no way about it. I mean, if you come in and you cut down a forest and then you plant nothing but wheat, you went from lots of biodiversity to no biodiversity because now you have one species growing in one area, wheat, and that's it. That's a problem, okay? Because what if a disease were to come in? All right. If a disease comes in, it's going to wipe out all your wheat, and there's nothing you can do about it because you have no genetic diversity, no resistance. Big problem there. Obviously, you're going to drive animals out and all that sort of stuff. In terms of soil, you have soil erosion, like what you saw on the previous slide. Typically, crops do not have deep roots like trees and things. So as a result, a lot of soil just washes away or blows away in the wind if they have just harvested and there's nothing there. You're going to lose fertility. Fertility is the availability of nutrients, those sorts of things in the soil. So if you plant crops there year after year after year and you're doing very high intense agriculture, then you're going to lose that fertility. Salinization. Okay. Salinization is when you repeatedly apply irrigation water and some fertilizer. And what happens is some of the water evaporates, but the fertilizer and the salt that may have been in the water just stays there. And over time, these salts build up, and they build up, and they build up, and they build up. And then the crops eventually die because most plants cannot survive in a salty soil. So in class, we're going to test the germination rate of different plants under different salty conditions and see which ones are salt tolerant, which ones are not. Waterlogging is another soil problem. If you've ever looked across the street, across Mountain Road from where the school is, at that horse farm, those horses have packed that soil down so tight that when it rains, they basically just get a pond in their front yard because the water cannot drain through the soil anymore. And I've already talked about desertification. Other problems, air pollution. Okay, major air pollution problems come from fossil fuels if you're using tractors. Also, some air pollution comes from the animals themselves. Okay, cows, for example, put out a lot of methane. Naturally, this isn't a problem because the cows are generally spread out. They're not a huge population. But when you start farming them and you put them in factory farms where you've got cows touching each other, basically, then that's a lot more methane per area, so you have a bigger problem. And finally, water pollution. Okay, you're going to have eutrophication, which, remember, eutrophication is when fertilizer, like nitrates and phosphates, okay, part of the nitrogen cycle that we disrupt, run into the water. Then you have an algae bloom, because the carrying capacity of water, especially for algae, is usually limited by the amount of nitrates and phosphates. So if you add more nitrates and phosphates, then that resource level grows, so then the algae are allowed to grow exponentially again to the new carrying capacity. Algae, of course, float on the water, and so they block out the sunlight, and they use up a lot of oxygen. So then the fish die. So this is why you're seeing the fish kill in here. Just having sediment pollution is also a problem. Just having soil run into water, like the water you see around here is very, very brown all the time. That's not normal. That's because there's so much construction and other things around here that the soil is running off into the streams and rivers and causing it to look brown because there's so much dirt suspended as sediment within the water. All right, so those are your four major problems. You've got biodiversity problems, soil problems, air pollution problems, and water pollution problems, all from just agriculture because of the way we do it. So how do we fix it? Okay, how do we fix our current agricultural problem? Well, let's think about it. All right, how can we keep the soil from eroding? How can we keep nutrients in the soil? How can we keep these things out of the water? Think about all these things. And now we're going to turn our attention to animals. Okay, so a lot of that was all crop production. Well, let's look at animal production. What are some problems with animal production? Think about your ecology unit and your energy efficiency. Okay, laws of thermodynamics. What do you think? Better to eat higher on the food chain or lower on the food chain? When we did our net primary productivity lab, we could feed one farmer per year on something like 3 million grasshoppers. But if you had 90,000 grasshoppers, you could feed 3,600 people for a year. So, which is better? Do domestic animals erode soil faster than crops? I don't know. What do you think? Animals are moving around, crops are not. Crops also have roots, which hold soil in place. Animals don't. What do you think? And is it ecologically sound to kill a large number of wild species? And then, of course, the moral question. Is it just right to eat an animal? Okay, plants don't have nervous systems. Animals do. So is it okay? And we're not going to touch on this question much. It's just something to think about within your own life and maybe talk with your parents about and see what they think. But this is environmental science, so we're going to cover these three questions. Okay. So meat production. Yeah, this is a feedlot. Okay, in some part of the United States, and you can see there are lots of animals packed into this probably 1 acre facility. A feedlot is commonly called factory farming by the media, because the idea here is to raise an animal to maturity, to adulthood, to, food status as quickly as possible, and then kill it and sell it. Rangeland is where we allow animals to just go out and graze. Okay, this is more the natural way to do things. So they just go out and eat the grass, and when you're ready to go get one and kill it, you send out the cowboys. They go get it, bring it back to the slaughterhouse. And then pasture. Pasture is cropland that is designed for animals. So we talked about that earlier in another video, where I said the pasture land, this is cropland, but you're growing food specifically for animals, not for people to use. So some problems with factory farming. All right, we know this is pretty natural. This is the cropland, so that falls under the crop problems we've already talked about. What are some problems with factory farming, or industrialized meat production, as the people who do it call it? Pollution, extra nitrates. Okay, that many animals packed into a small area, you've got lots of urine going into the ground. Urine is packed full of nitrates. Okay. Obviously, the odor, it's impossible to not drive past one of these things, and it smells absolutely terrible. And then, of course, the methane production for air pollution, which are greenhouse gases. Methane is a lot worse than carbon dioxide as a greenhouse gas. You're going to put pressure on other food sources. If you're going to feed all those animals, then you need to grow food for all of them. That's a lot of corn and wheat that's being taken away from people and given to animals. Again, if you're eating higher up on the food chain, okay, you're losing energy. You're losing your primary productivity as you move up the food chain, as you move up the trophic pyramid. So it's really expensive to eat at the top of the food chain, and that reflects in food prices at the store. If you go to the store and you want to buy a pound of steak, it's going to cost you, $12, we'll say. All right. If you buy a pound of pasta, it's going to cost you 99 cents. So it reflects in the price. And then if we're talking about fish, you're going to have major problems with feeding the fish. All right. And then you've got other problems. Fossil fuels. It takes a lot of fossil fuels to run these factories, to keep the animals penned in, all that sort of stuff. And then you've got the spread of infectious disease. If one of those cows on that feedlot were to get hoof and mouth disease, it is extremely contagious. In fact, the FDA would probably request or enforce that every single one of those animals be killed and burned, because hoof and mouth is so contagious. And once an animal has hoof and mouth disease, you cannot eat it. Same thing with mad cow. And then desertification. All right, you saw there where those animals were penned in, there's no plants growing. So you've got some big problems there. And if you overgraze an area, if you have too many cows on a specific piece of area, whether it's small like that feedlot there, or it's huge, then you could have desertification if you're not watching and controlling your animal populations properly. So for fish, we do something called aquaculture. All right, this is basically factory farming of fish. Sounds like a great idea because everybody likes fish, everybody wants to have it, and we are overfishing the wild fish, so why not farm them and try and quote-unquote domesticate the fish? Well, the problems are that the fish that are farmed, that are done with aquaculture, are generally less healthy for you. They're higher in the bad fats and lower in the good fats. They are more prone to have disease. They they're just generally not as good, and they're not as good for the environment either. Same problems. You put lots of fish in an area, you've got lots of waste problems. You've got to feed all those fish, you're going to have disease problems. So the good part, okay, sometimes we can use recycled water to grow these fish in, okay, if you're growing indoors. Or you can constantly clean the water with wastewater treatment and keep the water clean. So then it's not as having as big of an impact on the environment. you have higher productivity. And if you're growing things like oysters, then they actually help clean the water that they're in, which is good. The bad is that some of these specially bred fish for factory farming will escape and get out into the wild and then mate. And so now you've got domesticated or artificial genes mixed in with wild genes. And it's a monoculture. Once again, lack of biodiversity, so you have disease and pest problems. Here's another graphic. This one's from your textbook, showing the advantages and disadvantages of fishing, or of aquaculture and marine culture. Okay, kind of basically what I said: increased yield, but you've got problems with disease, and the fish are generally less healthy for you. All right, so if we're farming fish, that's what we get. What if we're wild catching the fish? If we're out actually catching them out of the ocean, there's a bunch of different ways we can do that. So here, you've got your aquaculture, caged fish farming. But you can also do all these other things. Long line fishing is just like regular old fishing with a hook and string. The difference is that you're using hundreds of hooks at a time instead of one hook at a time. I've started to notice on restaurants around this area, they've started to put on their menu things like line-caught salmon. 9 times out of 10, this is not line-caught as in someone cast a hook and caught a single salmon and brought it into the restaurant. This is, they're doing long line fishing where they're catching hundreds of these at a time, multiple times per day. So it sounds fantastic. Yay, it's line-caught, okay, but, what? So what? Okay. Problems with line-caught fishing are you're not going to get animals caught. The problem is you might catch the wrong type of fish. You might be trying to catch salmon. You end up catching half salmon and half tuna. Well, you don't always want to do that. Drift net fishing has the same problem where you get what's called bycatch. Okay, it's what you don't intend to catch, but you do get it. Dolphins, whales, sharks, those sorts of things. This is a little bit worse than line caught because here the fish can just swim into it and get caught. Any type of fish. Here it might just be because the bait, or something. And sometimes they could get away. I mean, if you're using a small hook, a big fish is going to get away. Trawler fishing, this is you have the boat move along, and as they move, they drag a big net behind them that trawls along the ocean floor and just sweeps up all the fish. And finally, purse seine fishing. This is you have the boat circle the school of fish with a net, and then they close the bottom and just haul in the net. Okay, so like a purse from not modern day purses, but old purses like the leather pouches where you have the drawstring. That's where the name comes from. And so what are the environmental problems with this? Well, let's just examine this chart. Okay, mid-60s, high abundance of all types of fish generally. With high abundance comes lots of fishing. Well, what happens when your fishing harvest overcomes your abundance? Well, your population declines, and it continued to decline until the 1970s when they started putting laws in place. So they started saying, no, you cannot catch this all the fish you want. You can only catch what we say you can. So as a result, the harvest declined a little bit, so the abundance came up. All right, but now we're back into this decline. All right, there was just a small rebound, and now it's basically collapsed. There's not a lot of fish left. In fact, they're predicting that we're going to run out of fish by about 2030. Okay, fishing will become commercially extinct by 2030. So what does commercially extinct mean? Commercially extinct means that it is no longer profitable to fish the fish because there aren't enough fish to catch. Okay? So that's the problem there. Bycatch is what I was talking about in the last slide, where you're catching things you don't intend to catch. That's a big problem. Overfishing, this is what's demonstrated here. You're fishing more than nature can replace. And sustainable yield is the opposite of overfishing. You're catching enough that the population can rebound, and as a result, you can ultimately fish the fish theoretically for an indefinite amount of time, because the population will always be there. We've started to do this with crabs around Maryland. They've put enough laws in place now, like you have to throw back females, you cannot catch males over a certain age, or under a certain age, all these sorts of things. It has to be the crab has to be a certain size, all this sort of stuff. So that has allowed the crab population to rebound to become more sustainable in Maryland. And then we've already talked about aquaculture, which is the fish farming and fish ranching. Alright, so that is it for this video. Lots of vocabulary, okay? Lots of vocabulary, lots of new techniques, and lots of problems. So in class, we're going to go over the tragedy of the commons, which has to do with fishing and why these numbers are declining. And we're going to watch a couple of videos about factory farming and what are the problems there. Stay tuned. We've got one more video on food production and how we can solve a lot of these problems that I've talked about in this video. Alright, so I'll see you next time.